Now that re feditse ka your DNA and RNA, ra tlhaloganya your DNA le RNA ke re tlo lebella what you call DNA replication. But before we go DNA replication, are remember DNA ke nucleic acid. Nucleic acid, and then it has two strands. Basically, it will look like this. It only strand it's a bit, and then it coils up around the histone. The histone, deforming nucleosomes, and then forming chromatin. Further coils up until it form a chromosome. Good. And remember, nucleic acid is like the monomer. The monomer, the building block of the nucleic acid, repeated in nucleotides. And nucleotide basically is nothing more than the phosphate, a bondilele, the deoxyribose sugar. Remember right now, specifically. I'm going to choose thymine right now. It's a deoxyribose sugar. Good. So this whole thing, nucleotide. Whether ke thymine, adenine, cytosine, guanine, ke the nitrogenous bases. So take the nitrogenous bases. So nitrogenous bases, they form what we call base pairs. For example, thymine bond the weak hydrogen bonds le adenine. Adenine we bond le thymine again, weak hydrogen bonds. Guanine bond le cytosine. And then cytosine lona we wanna ibondale guanine. So these are nitrogenous bases. The former what we call base pairs. We're together, good. Well, regards more continue. Regards more DNA replication. Now, for DNA, why does DNA replication need to happen? DNA replication area because we have a copy ya DNA kamara cell A1. Remember during interphase, during interphase, even DNA ash are not DNA for the sake of it. Before cell A divide, a copy of itself. A copy of this DNA. It will go to the next cell during mitosis. During mitosis. So that's why copying your DNA replication just before the mitotic phase, just before prophase top. It's a copy the DNA. And it makes sense. If you do a cell and I get exact copy, same doulas, same DNA. The original cell. So at the end of the day, we end up with two cells that have the same amount and the same type of DNA. So that's why DNA replication is during interphase. So DNA replication is first things first. DNA unwind. We say DNA unwinds. So basically, we unwind it. What to low? Anchi is very quelled up. It's not look at the methapone, and not quelled up. So yata to low, yata to low. Why chancy that to low? Why chancy unwind? What to low? How unwind? Chancy is pellets eliso, Rocono Bonavano. Are you so? Are you ready? The base. The nucleotide base arena. The base pairs are. Since arareke A ibondali T gamo, A ibondali T gamo, G C. So G ibondali C, C ibondali G. So arareke for example here, arareke DNA yaron after A unwind. After I unwind the DNA yaron, now transi unzip. This DNA must unzip. We unwind and then number two, we unzip. Either because of help of enzymes and proteins. Good. Yeah, unzip to expose the nitrogenous bases or strand tse ding di khona go form. So the strand tse two tse ne, because ke di original di bidiwa di template strand ne, are e ke template strand 1 and the ka mo right e ke template strand 2 ne. Good. This is going to help us go pele e tlo thusa e level or go ira etseng ka di template tse ne. Good. Then for the unzip the hydrogen bonds tse di tshwereng di nitrogenous base ke bolela ka nako ke bolela ka di hydrogen bonds tse di between A and T, G and C and C and G. Di now di hydrogen akere di weak then di a breaker bene di breaker strand tse two tsela di unzip bene di a zipoloha bene o ka o zipolla before ya 69 da so ne. Good. So has ne di unzip o bona ka sa tso ona le strand tse pedi tsela the template strand tse pedi tsela shedile. Now the nitrogenous bases tsela di exposed ne, di exposed go form a new strands. Akere rile ke adenine le adenine, guanine le cytosine ka ntlhela after still ke thymine akere ne bondile le adenine ke thymine nngwe ke cytosine ne bondile le guanine la and then ke guanine ne bondile le cytosine. Then no strand se formiwa kae bjang nucleotide bases tse di tlhaka di ntse di le zwaki di rile ona ka marasele ka mona ne. Then di teng mo gotlhe ke tsona shedile ke tsona they are called free living nucleotides or free nucleotides, not free living, free nucleotides ne. Ke di free nucleotides di teng mo gotlhe mo di teng shedile di free nucleotides di teng. I think we rale sepe ka tsona di na span di tshitsi fela. Those free nucleotides tsona tse senang span tseo ke tsona tse e leng gore di tloya di bond re tlhokang gape re tlhoka C yo swima shile e tla mo re tlhokang gape re tlhoka T le yona yo swima shile e bonda mo T nngwe e bonda mo subsequently o hila the same ka daso ka mo right ka mo template strand ya number 2 ne C ela yo tla mo e bonda. So at the end of the day after it unzips the free nucleotide shedile bjanong di ready forma di strand tse di. Now di strand tse di formegang tse di mpšha a ke di formegang mo the original strands tse di bitsang di template strand tse di mpšha tsela re di bitsa di complementary strands. So complementary strands form ne, from where they form from the free nucleotides bjang are boileng ga papes color roy are bekse color black color ya manyoro ne bjang akere originally we had this ne? We had this original strand 1 2 3 4 1 2 3 4 ne. Now re ke berekise color go bontsha tse ke di complementary strand tse ding di a forma ka tabelo ne. Ke tla bitsa complementary strand number 1 and complementary strand number 2 e forma mo kae e forma mo template strand number 1 a di forma bjana. Now remember re na leng kae re na le A re na le A adenine nngwe re na le guanine re na leng cytosine. Now I told you gore go iragala another thymine ye tla tlo bonda le adenine. Same applies to this adenine. Guanine you attract cytosine and cytosine you attract guanine. That's what really happens. Ne? And then lekamo another complementary strand ya formula. I can remember strand is nale thymine ke template ya bobedi bjano ke thymine cytosine le guanine ne. Then the free nucleotides di etla hapa le ka mo template strand number 2 di forma complement strand number 2 bjano ho tla mo thymine mo ke adenine ho tla adenine nngwe bonda le thymine ka di-weak hydrogen bonds ka lebala or guanine e fetsa mo re cytosine ebang re lebella pele o ka checka tabe o DNA e tshwana le DNA e leng ka iso re na le complementary template strand number 1 and template strand number 2 and then ho irahalang ka tsona di tlo nna a template for complementary strand number 1 and complementary strand number 2 how re lebella pele for the one man re na le the same amount of DNA and the same amount of nucleotides AT GC CG AT GC CG the same amount of DNA, the same amount of chromosomes, then one of these will go to the next cell and the other one it will remain the mother cell and then the daughter cell will get the exact same amount of DNA. Basically kiona DNA replication. That's why you have the same amount of DNA, the same type of DNA for the next cell that is being formed. Good. Are feletse kae? Are qoventa be so re qobella tabe kae? Re qobella tabe ka with a simulation e. Are DNS your DNA. Are ya ka pele. Are DNA ya ho ka pele. We can already tell that this is a DNA strand by what? Re kono bona kae? Ka thymine. And then the base pairs are on. Re tshwina base pairs are na right sorry T le A C le G bonda wena man. Rubbish. Shile. Yatse. Hawa. Yaha na itse. Shile yatse banna. No, the hydrogen bond did switch. So the bond ki strand sa rona ki complementary strand number 1 no template strand number 1 template strand number 2 good now ho irahala arbo sela ko morao ke rat ra itse di jala ka mara nucleus tabe good because of the help of these other enzymes aro di bolela ka mai yanzi bona jile those enzymes break up the weak hydrogen bonds now rena template 1 template 2 di butsi bjano the free nucleotides di ka are nya ke free nucleotides now the enzymes di atle di go thusa bjano bona ya thoma bjana ya thomeng tabe are building the complementary strand are thomeng ka mo left cam re build up complementary strand kamara motho kwa template strand right dia match A T le A G le C wa berekea wa bona se dira kopi di a tswa re tse se sefigile manje bonda wena hydrogen bond bonda wena referees efetsa la le yona ila la kana kwa 1 una po itse la le yona e builder ya yona in the opposite direction mara ro tsena mo tabeng ya direction e tlo bola direction ka di bola batho fa shile then the referees bon de girala down run strand tse pedi tsa o tswana DNA tse pedi tsa o tswana o ka lebello o tla go dimo ke ma twins pya itswi wa bona so that is a whole DNA and re bona kae re ka nna ra bala di nucleotides a 1 2 so now 2 4 6 8 10 2 4 6 8 10 2 4 6 26 at about 2 4 6 8 10 12 14 16 18 20 22 23 24 26 the exact same amount of nucleotides and the same amount of DNA referees to DNA replication and then one of these nucleotides one of these DNA will go to the next cell and then the other one will remain in the mother cell now be referees aboard I'm not DNA replication name not it maxima hala ba fa tsona sasa pya 2 ja ne great